Hello students, this is lesson 9 in module 3, writing and solving equations using if-then statements. Our essential question is, how do I solve an equation? Our opening exercise question. Heather practices soccer and piano. Each day she practices piano for 2 hours. After 5 days, she practiced both piano and soccer for a total of 20 hours. Assuming that she practiced soccer the same amount of time each day, how many hours per day, H, did Heather practice soccer? Pause the video for a moment and write the equation to solve this problem. Heather practiced soccer and piano together, and she did this every day for 5 days. So the sum of those practices will equal 20 hours. The amount of soccer practice, we don't know, but we're going to use H for the number of hours, and the amount of piano was 2 hours. This is 1 day's worth of practice, soccer plus piano. She did this for 5 days. So 5 days times the number of practice hours totaled 20 hours. Pause the video and write an equation for the next problem. Over 5 days, Jake practices piano for a total of 2 hours. Jake practices soccer for the same amount of time each day. He practiced piano and soccer for a total of 20 hours. How many hours, H, per day did Jake practice soccer? So again, the total is 20 hours, and Jake practiced piano and soccer. We know that the piano practice was 2. But it is 2 hours total, not 2 hours per day. The soccer is the same amount of time per day for 5 days. 5 days and H hours per day is written as 5H. And the sum of the soccer hours plus the piano hours equals 20. Examine both equations. How are they similar? How are they different? They are similar in that they both have the number 5, 2, and 20. They're similar that they both use H for the variable for the number of hours of practice for soccer. And how are they different? The difference is the amount of piano that they practiced. Do the different structures of the equation affect the answer? Explain why or why not. Well, let's look at the structure of the equations. For Heather, the structure was 5 times the sum of H plus 2. And for Jake, the equation is 5H plus 2 equals 20. So if we distribute the 5 to the practice daily, that gives us 5 days times H hours per day, plus a total of 10 hours for piano. And if we compare that to Jake's equation, Jake practiced only 2 hours of piano and Heather practiced 10 hours of piano. Since they both had a total of 20 hours of practice, you can see that Jake will have more soccer hour practice total than Heather would. We're going to skip the next 2 questions and move on to example 1. For example 1, Fred and Sam are a team in the local 138.2-mile bike run-a-thon. Fred will compete in the bike race and Sam will compete in the run. Fred bikes at an average speed of 8 miles per hour. Sam runs at an average speed of 4 miles per hour. The bike race begins at 6 a.m., followed by the run. Sam predicts he will finish the run at 2:33 a.m. in the morning, or the next morning. The next morning. So let's write down what we know. We know the total amount of miles ridden is 138.2. We know that that is made up of biking and running. We know that the team is made up of Fred and Sam. And Fred is riding the bike, and Sam is running. We know that Fred's speed is 8 miles per hour, or 8 miles in 1 hour, and we know that Sam runs at a speed of 4 miles per hour, or 5 miles, or 4 miles in every hour. How many hours will it take them to complete the bike-a-thon? They start at 6 a.m. in the morning. They bike all day, all afternoon, all evening, and run, and don't finish until 2:33 a.m. So the total distance can be calculated. Figure out first, how far is it from 6 a.m. till noon, and then from noon till midnight, and then midnight till 2:33 a.m. So 6 a.m. till noon is 6 hours, noon till midnight is 12 hours, and midnight till 2:33 is 2 hours and 33 minutes. Putting these hours together, we get a total of 20 hours and 33 minutes. We will need this calculation later in the problem, so instead of leaving it in 2 different units of measure, hours and minutes, we're going to convert it to all hours. So that will be 20 hours, and 33 minutes is 33 out of 60, and 33 out of 60, let's convert that to a decimal so it will be easier to use. 33 divided by 60 is 0.55. 20 hours and 55. So 20.55. Now this is not 20 hours and 55 minutes, it's 20 hours and 55 hundredths. So let's see, our total time is 20.55 hours. Question B. If T equals how long it takes Fred to complete the bike race. Okay, so T is going to be Fred's time. Write an expression to find Fred's total distance. To find Fred's distance, there is a distance formula that we can use. The distance formula is distance equals rate times time, where D represents the number or the distance traveled, R represents the speed traveled in miles per hour, and T represents the time in hours. So we're looking for D. We know that the rate is 8 miles per hour, and we're looking for the time. Let's move that D here. There we go. Now it says to write an expression for this. So the expression for Fred's distance is simply 8t. That represents Fred's distance. Continuing. Write an expression in terms of t to express Sam's time. Now, Sam's time, we know the total amount of time, and we know the amount of time that Fred took was 8t, or t. And now we want to calculate Sam's time. So if we take the total and we subtract Fred's time, that will give us Sam's time. We calculated the total time on the previous page to be 20.55. We wrote a variable for Fred's time on the previous page, which is t. And this is the expression that will be used to calculate Sam's time. Write an expression in terms of t that represents Sam's total distance. Again, the distance formula is distance equals rate times time. So we want Sam's distance. We know that Sam's rate is 4 miles per hour, and Sam's time is expressed right here. So we'll multiply 4 times the expression for Sam's time, which is 20.55 minus t. So the expression for Sam's total time is 4 times the quantity, 20.55 minus t. And again, this represents Sam's distance. Question E. Write and solve an equation using the total distance both Fred and Sam will travel. To find the total distance for Fred and Sam, we'll write Fred's distance plus Sam's distance. Fred's distance from the previous page was 8t. Sam's distance from above is 4 times the quantity, 20.55 minus t. And this is an equation to find the total distance. We know the total distance from the given information was 138.2 miles. Now let's solve that equation. We'll use PEMDAS to simplify our expression before we solve for the variable t. So we look for parentheses. You cannot solve what's in the parentheses without knowing the value of t yet. There are no exponents. For multiplication, we do have 4 times this quantity, so we will do that first. Bring down the 8t. 4 times 20.55 is 82.5 minus 4 times t is 4t, and that is equal to 138.2 miles. Then we will use addition and subtraction. We can subtract 4t from 8t using any order. 8t minus 4t is 4t plus 82.5 is equal to 138.2. So we're done with PEMDAS. Now we'll use PEMDAS-O, and the O stands for opposite, and now we'll go in the opposite direction of PEMDAS to solve for t. In the opposite direction, we undo addition and subtraction first. So we'll undo this addition, subtracting 82.5 from both sides of the equation. This is an if-then statement. Simplify. 82.5 minus 82.5 is 0. 0 plus 4t is 4t. And the subtraction on the right side of the equation, and that gives us 56. Next on PEMDAS, working backwards, is to undo the multiplication with division. Divide by the coefficient of 4. An if-then statement says that you can divide both sides of the equation by 4 and it will remain equal. 4 divided by 4 is 1, 1t, and 56 divided by 4 is equal to 14. So t represents the time, and that time is actually Fred's time. Remember that t from the previous page stands for Fred's time. So we have Fred's time as 14 hours, and we know from above here this is Sam's time, 20.55 minus t. So we'll subtract 20.55, subtract 14 hours, and that gives us Fred's time. So Fred's time is 14 hours, and Sam's time is 6.55 hours. And that total is the 20 hours, 20.55 hours. So we've calculated the amount of time each person takes on the race. The next thing that we want to do is find out how far did Fred bike and how far did Sam run. So we'll go back to our distance formula. Distance is equal to rate times time, and we'll substitute what we know. For Fred, The distance is equal to 8 miles per hour times 14 hours. And so Fred's distance is 112 miles. For Sam, the distance is rate times time, and Sam's distance, his rate was 4 miles per hour. And his time was 6 hours, 6.55 hours. So his distance is 26.2 miles. Another way to figure that out would have been 138.2 total miles minus the 112 miles total, and that would equal 26.2 miles. So this is Fred doing the biking, this is Sam doing the running. Next, this table is a way to organize the information and figure out from the total time and Fred's time, how much did Sam take. So if the total time was 10 hours and Fred's time was 6 hours, 10 hours take away 6 hours would have been Sam's hours. So if the total time here and this is Fred's time, then this would have been Sam's time. So we've got, if Fred took 15 hours, take away the 12 hours, then Sam's time would be 3 hours. And if Fred had 20 hours, if the total was 20 hours, take away 20 hours minus 8 hours is 12 hours. Total 18.35 minus 8 hours is 10.35 hours. And this represents the total amount of time for the race minus Fred's time, and that will equal Sam's time. So that is represented 20.55 minus t. Now let's take the information that we used and create a table to organize this problem. We'll start with the total for each time and subtract Fred's time to find Sam's time. So setting up our table, on the left side we'll have the two athletes' names, Fred and Sam. And we'll write the three main components of the problem, which were the rate in miles per hour, the time, which was in hours, and the total distance, which was in miles. The rate for Fred was 8 miles per hour. The rate for Sam was 4 miles per hour. The time in hours for Fred, we used t, and then for Sam, it's the difference between the total and Fred's time. So 20.55, take away t. Then the distance in miles. Fred's distance was 8t, and Sam's distance was 4 times the quantity, 20.55 minus t. And let's simplify that. That's 4 times 20, that was 82.5, and 4 times t was 4t. So this was the total time, take away Fred's time to get Sam's time. And this 82.5 minus 4t is Sam's time. Next, this is on your next page here. Why isn't the total time from 6 a.m. to 2:33 a.m. written as 20 hours and 20.33 hours? Well, 20.33 represents 20 hours and 33 hundredths, and that 100 would mean that there are 100 minutes in one whole hour. In one whole hour, there are 60 minutes. So this minutes as a fraction of an hour, the denominator would be the whole, which is 60 minutes in one whole hour. And then we calculated that as a decimal. 33 divided by 60 is 0.55. Example 2. Shelby is 7 years old, 7 times as old as Bonnie. If in 5 years the sum of Bonnie and Shelby's age is 98, find Bonnie's present age and use an algebraic approach. We'll use what we learned on the previous section about setting up a table to represent this. We'll put their two ages on the right side of the table. So we have Bonnie's age and we have Shelby's age. And Shelby is 7 times as old as Bonnie. So you know a little bit about Shelby, but nothing about Bonnie. Since we know nothing about Bonnie, we'll use X for her age. And Shelby is 7 times as old, so her age will be represented with 7X. Now, this represents their present age. And it says, if in 5 years. So let's let this column represent the future age. If in 5 years. So Bonnie in 5 years will be 5 years older. And Shelby will be 5 years older as well. So this represents their age in 5 years. And we know that the sum of their ages will be 98. So we'll write that out. X plus 5 represents Bonnie's age, plus Shelby's age, represented by 7x plus 5, and the sum is 98. And we'll solve for x. When we solve for x, we'll be finding Bonnie's age. So this is all addition. Since it's all addition, you can remove the parentheses. So here we have x plus 5 plus 7x plus 5 is equal to 98. And we can use the properties of addition to reorganize our problem. Combining our like terms, x plus 7x is 8x, 5 plus 5 is 10, and that is equal to 98. Now we can use PEMDASO. The O stands for opposite, so we'll work opposite on the order of operations, undoing addition and subtraction first. Undo this addition with subtraction. Subtract 10 from both sides of the equation. That's an if-then statement. Simplify. Bring down your 8x. The plus 10 and the minus 10 equals 0, and 0 plus 8x is 8x. 98 minus 10 is 88. Next, undo multiplication or division. This is multiplication. The opposite of multiplication is to divide. Divide both by the coefficient. 8 divided by 8 is 1. 1x is written as x. 88 divided by 8 is 11. So here's the solution to the equation, and x represents 11. X represented Bonnie's age, and the question was to find Bonnie's age. So 11 is Bonnie's age.